How did water get to Earth? When Earth was first formed, it likely did not have any water because the temperatures were over 100 degrees Celsius. This would cause water to boil and evaporate, and therefore Earth was not considered to have water during these early formation times. There are lots of theories out there trying to figure out how water actually got to Earth, but the most widely supported hypothesis thus far is that water got to Earth by asteroids colliding with the Earth and bringing water with them. During the first few hundred years that Earth was forming, there were lots and lots of asteroids bombarding the Earth, so extremely high rates of asteroids. And then it slowly started to slow down about 2.5 billion years ago. It became much slower. So now it's about once every 20 million years. These were also likely to be younger or newer asteroids, as asteroids that are billions of years old don't have a lot of water still within them because it will evaporate from the sun or due to gravity being too weak around the asteroid, which means it wouldn't be able to contain the water vapor near the actual asteroid. Once water got to Earth, how did Earth retain the water? Well, there's two important things that we need to consider. The distance of Earth from the sun allows for the sunlight to not raise the temperature of the Earth high enough to boil water. Therefore, water remains in a liquid form more often than it remains in a vapor or gas form. It's easier for Earth to retain that liquid water because the cohesive forces or hydrogen bonds between water molecules is strong, and that makes it easier for retention. Water vapor lacks those bonds. The second thing is that Earth, due to its size, has a relatively strong gravity, and this allows for Earth to hold the liquid water, or the oceans, very tightly to its surface, and also allows for it to hold the gases within the atmosphere. So due to this, there's very little water that actually escapes from Earth's atmosphere. There is evidence that Mars may have had liquid water on it at one time, but it's thought that it used up that liquid water in chemical reactions due to the types of minerals that are present within the rock on Mars. But since Earth doesn't have as much of these particular minerals, its surface water was not used up, and that also allowed for us to keep water here on Earth. One thing we know is that we need water for life. So the abundance of water over billions of years throughout Earth's history has allowed life to evolve. Scientists are always searching for other planets out there that may be similar to Earth, or at least may have life on those planets. There's so much about the universe that we do not know. So there's always searching for that. But one thing they think is true is that in order to have living organisms on a planet, that planet would have to have water. And that planet would also have to have a rocky surface, like Earth. Not, for example, a gas planet. So we're always looking for planets that are kind of similar to Earth. In the fairy tale, Goldilocks and the Three Bears, Goldilocks is known for trying 3 bowls of porridge. When Goldilocks does this, she finds that one of the bowls of porridge was too hot, one of the bowls of porridge was too cold, and one of the bowls of porridge was just right. This is actually a metaphor for the habitable area around a star that they do call the Goldilocks zone. The reason it's called the Goldilocks zone is because if a planet is too close to a star, water will evaporate because the temperature will be too high. If the planet is too far from a star, the water will freeze on the surface of the planet, and therefore the temperature is too cold. But if the planet is in the Goldilocks zone, water remains a liquid because the temperature is just right. Therefore, this would be needed for life. So again, that area within around a star that's considered the habitable area for potential life is called the Goldilocks zone. This means that Earth is in the Goldilocks zone around the sun. The location of the Goldilocks zone depends on the size of the actual star. That's going to also determine how hot it's burning and how much energy it's able to actually emit, but also the size of the planet. The more planets that are present in a Goldilocks zone, the greater the chance that extraterrestrial life has evolved. So again, scientists are always looking for planets that are similar to Earth. This is just a fact, FYI. You won't be tested over this fact, but FYI, scientists estimate 40 billion planets within a Goldilocks zone within the Milky Way galaxy alone. And so imagine all the other galaxies out there with their potential Goldilocks zone. In this particular image, here's the Goldilocks zone in green. So again, here's the Goldilocks zone of our solar system right here, and here's Earth. In 2014, in a different system within the Milky Way galaxy called the Kepler-186 system, scientists did locate a planet. They've named it Kepler-186f that is within the Goldilocks zone of that particular system, and they think it could potentially have liquid water on it. It's similar in size to Earth. I think it's only around 10% larger than Earth. And the star is smaller than our sun. However, it is within the Goldilocks zone. But because the star is smaller, potentially the temperatures could be much cooler on this planet. But they do think that potentially it could have liquid water on it, and it's the first planet that we found that is similar in size to Earth. There's still a lot we don't know about this planet. For example, they don't know for sure if it's a rocky planet or a gaseous planet, and we think it would have to be rocky in order to support life. So still learning, right? Still learning things out there, still discovering new things out there in space. And this is another thing that you won't be tested over this specific thing, but I did want to give you an example out there of, what NASA is looking for and where we are currently in this information. And that's it for this new little section of notes.